Hi everyone, in this video we are going to see how to find the equation of family of circles that go through the points of intersection of a circle and a straight line. Let's suppose you have a circle like this, and let's suppose you have a straight line like this which intersects the circle at 2 points P and Q, and let's suppose the coordinates of the points P and Q are like this. P's coordinates are x sub 1, y sub 1 and Q's coordinates are x sub 2, y sub 2. Through the points P and Q, how many circles can we draw? Well, I'm going to draw a few and then you will realize how many actually we can draw. We can draw a circle like this that goes through the points P and Q. We can draw another circle like this that also goes through the points P and Q. We can draw another circle like this that also goes through the points P and Q. We could draw another circle like this which also goes through the points P and Q. So as you can see, we can actually draw infinite number of circles that could go through the points P and Q. Now let's see how we can find out the general equation for this infinite number of circles. Since the original yellow circle passes through the points P and Q, its equation must satisfy the coordinates of P and Q. First, I am going to satisfy the equation of the first circle with the coordinates of the point P. So we can write it like this. S sub P is the left hand side expression of the equation of the circle when satisfied by the coordinates of the point P. Next, I am going to satisfy the equation of the straight line with the coordinates of point P, and let's call the left hand side expression as L sub P. Next, I am going to satisfy the equation of the circle with the coordinates of point Q, and let's call the left hand side expression as S sub Q. And then I am going to satisfy the equation of the straight line with the coordinates of the point Q, and let's call the left hand side expression as L sub Q. Now I am going to assign a number to each of these equations. Now let's try to add equation number 3 and 4 and see what happens. That means we are going to do S sub P plus L sub P equals 0, and if we plug in the values of S sub P and L sub P, then our equation would look like this. And if we rearrange the terms a little bit, our equation is going to look like this. And then I'm going to rewrite the equation in such a way that the x sub 1 term and the y sub 1 term, they will look slightly different, but they will look like the general equation of a circle. So we can rewrite the equation like this, and then we can write it in a simplified form which is kind of like this, where g sub 1 is actually 2g plus a over 2, and f sub 1 is actually 2f plus b over 2, and c sub 1 is actually lowercase c plus uppercase c. Lowercase c is the constant term for the equation of the circle, and uppercase c is the constant term for the equation of the straight line. Now if you carefully look at this equation, it is actually looking like the equation of a circle whose center would be located at negative g sub 1, negative f sub 1, and of course its radius would be square root of g sub 1 squared plus f sub 1 squared minus c sub 1. So just by adding the equation of the circle and the straight line when satisfied by the coordinates of the point P, we come up with the equation of a circle which also satisfies the coordinates of the point P. That means this is the equation of a circle that goes through the point P. Next, we are going to do a similar operation. Let's add equation number 5 and 6, which means we are going to do S sub Q plus L sub Q equals 0. If we plug in the values, our equation will look like this, and then if we simplify a little bit, our equation will look like this. And if we rewrite the x sub 2 term and the y sub 2 term, our equation is going to look like this. And if we write it in a simplified form, we can write the equation like this. So now if you carefully look at this equation, again it will look like exactly similar to the previous one that we derived. The only difference is that here the equation is satisfied by the coordinates of the point Q. This is also the same circle whose center is located at negative g sub 1, negative f sub 1, and radius will also be same, which would be square root of g sub 1 squared plus f sub 1 squared minus c sub 1. But this equation also indicates that the circle is also satisfying the coordinates of the point Q. That means just by adding the equation of the circle and the equation of the straight line, we are able to come up with the equation of a circle that is satisfying the coordinates of P and coordinates of Q. Next, we are going to try a similar operation. We are going to add equation number 3 with k times equation number 4 and see what happens. So our equation will look like this, and if we simplify a little bit, our equation will look like this. And if we rewrite this equation, then it would look like this. And if we write it in a simplified form, we can write it like this. Now if you carefully look at this equation actually represents the equation of a circle when satisfied with the coordinates of point P. So just by adding equation number 3 with k times equation number 4, we are able to come up with the equation of another circle which also goes through the point P. And I'm going to do an exactly similar operation with equation number 5 and 6. and by doing that we are getting an equation like this, and I'm going to simplify it a little bit. So our equation would look like this, and if we rewrite the equation in the general form of the equation of a circle, then our equation could look like this, and then finally if we write it in a simplified form, our equation would look like this. So here again we came up with the equation of the same circle whose center is located at negative g sub 2 comma negative f sub 2, and whose radius would be square root of g sub 2 squared plus f sub 2 squared minus c sub 2, is the same circle, but it is also satisfying the coordinates of the point Q. So you see, simply adding the equation of the circle with k times the equation of the straight line, we are able to come up with the equation of a circle that is passing through the points P and Q. So now if we write the general form of these two equations, our general equation would look like this. We can say the general equation will be S plus k times L. S is the left hand side expression of the equation of the original circle, and L is the left hand side expression of the equation of the original straight line. So S plus k times L essentially giving us the general equation of all those circles that are passing through the points P and Q. Of course their radius would be different, but they all will be passing through the points P and Q. And of course k is a real number, any real number will work, and that's exactly what we needed to derive. So this general equation actually represents the family of circles that will be passing through the points of intersection of a given circle and a given straight line. I hope the derivation made sense. Thank you for watching. See you in the next video.